Hello, good morning, good afternoon and good evening, and welcome to another episode of What's New in Simcenter STAR-CCM Plus from engineer to engineer. I'm Rodolfo Piccioli, and today here with me in the London Hammersmith studios is my colleague Laura Trappolini. Laura, welcome to the London Hammersmith studios.
Thank you, Rodolfo. Hello, everyone.
So despite the very Italian name, you're actually not Italian.
No, I'm not Italian. I'm Belgian, actually.
Do you want to say something about yourself?
Yeah, sure. So I am Laura Trappolini. I live in France, but I come from Belgium. And I'm the technical product manager for SPH and turbomachinery application.
All right, so you're here today to talk about some exciting new features of Simcenter STAR-CCM Plus 2402.
Yeah, for sure. There are very exciting features coming up.
Yes, so Laura, you traveled not today, but yesterday from Nantes.
Yes, from Nantes in France, yes.
And may I offer you a coffee just to start?
Sure, that'd be lovely.
Absolutely. Hello.
Thank you.
Good, I hope you appreciate the British coffee as well.
Yeah, it's good, it's good.
All right, so Laura, the first feature you are going to talk to us about today is SPH, which for the members of the AAAA, which is the Association Against Acronym Abuse, stands for Smooth Particle Hydrodynamics. Please go ahead.
Yes, so in Simcenter STAR-CCM Plus 2402, we're integrating the first release of the SPH technology. So SPH, as you said, stands for Smooth Particle Hydrodynamics. And the biggest benefit of the SPH technology is that it is meshless. So you do not require volume meshing to set up the SPH simulation. And also you don't need complex techniques to set up the motion. So you just need to set up the rotation speed of each of the solid, and that is enough in terms of setup. The other benefit of this integration is that it's fully integrated into Simcenter STAR-CCM Plus, so it beneficiates from the advanced pre-processing through 3D CAD, also the expert post-processing, and it works out of the box with the design manager. So you can do design space exploration already with SPH in the 2402 version.
Yes, we are seeing here in this video how actually easy it is to set up SPH in Simcenter STAR-CCM Plus now. One question, what applications are we specifically targeting in this first instance of SPH?
In this first version, we're targeting gearbox lubrication applications.
Right.
And so we can do in terms of monitoring, we can monitor the churning losses, so look at the torque evolution, and we can of course also look at the evolution of the particles in the domain.
Wow, it is so exciting that we can do these gearbox cases directly in Simcenter STAR-CCM Plus now. And Laura, I have a question. Can you comment about performance?
Yes, so for example, to run a gearbox simulation of about 500,000 particles on 8 cores, it will take approximately 1 hour, but you can run the same simulation on 64 cores and it will take about 10 minutes. So we have very good scalability in Simcenter STAR-CCM Plus using SPH, and we can go below 8,000 particles per core and still have a very good scalability in terms of performance.
Excellent, all right. One last thing, do you want to say something about licenses?
Yes, so to be able to run the SPH solver, you will need an additional license, not for the pre-processing and post-processing, but to run the SPH simulation.
Right, thanks Laura. Very, very exciting new feature to start with. We have a lot more to follow, but for the next feature we connect to a colleague remotely, Costas, who will talk to us about interactive classification of part surfaces in surface repair. Hello Costa, how are you today?
Hello Rodolfo, I'm really good, thank you. How are you?
I'm doing great, thanks. So today you are going to talk about a feature with a very long name, which is interactive classification of part surfaces in surface repair. Please tell us more.
This new innovative tool that really expedites the process of surface preparation within surface repair. So it really expedites the process, for example, of splitting part surfaces for A and B surfaces in automotive applications, or for example in pre-processing if you want to extract a particular part surface for applying boundary conditions, for example, a heat load. This tool will really expedite the process and makes the workflow easier and faster. In external aerodynamic simulations, the splitting of A and B surfaces could be of paramount importance for ensuring the right number of prism layers where it is really required. Let me show you an example of a front bumper here. Often, imported tessellated parts consist of only one part, and the process of splitting part surfaces could be really time-consuming depending on model complexity when we use native surface repair tools. To address this problem, in Simcenter STAR-CCM Plus 2402, we're introducing a new interactive classification tool in surface repair that speeds up the process of splitting part surfaces. The Classify tool and other surface repair tools are now located in new vertical tabs. The user can pick target points on the surface of the part, and based on specific input values, the size of the resultant classified area can be controlled. Closed loop gaps can also be filled automatically with the click of a button. And as you can see now, the exterior part of the front bumper has been classified, and a new part surface can now be created for further pre-processing. The feature comes also with a certain degree of automation, and for more details, you can contact our support team, and they will be happy to give you support and provide you with all the details that you need. Thank you very much.
Okay, Costa, thanks a lot for this. Right, Laura, back to you. So you said at the beginning you are product manager for SPH and turbomachinery, and now you already spoke about SPH, and now back to turbomachinery, I would say.
Yes, exactly. So in Simcenter STAR-CCM Plus 24.2, we are also releasing a turbomachinery feature. Now in the turbomachinery structured mesh, we now support the fillets for the blade. So the fillet can be either at the hub or at the shroud. And to be able to use it, it's really seamless for the user, because you just need to have your fillet surfaces with the blade surface, and there is no additional user input.
Right, I guess a lot of friends watching from home wondering now what are the benefits compared to the polyhedral mesher.
Yes, exactly. So the benefit of the structured mesh is that first it has fewer cells compared to polyhedral mesh, so it leads to a faster turnaround time. But not only with the structured mesh, you also have these flow aligned cells in the main blade passage, so it allows to have a faster convergence of your simulation and also an increased accuracy compared to poly.
Okay, excellent. Sounds very, very good. Okay, so for the next feature, Laura will stay here, but we connect to another colleague remotely. And please join me welcoming Liam to the stage.
Hi, Liam.
Hello, Liam, Mr. GPU.
Hi, Rodolfo. Thank you.
Good. So what are you going to talk about today?
Well, I think you gave it away a little bit there with the Mr. GPU. So yeah, I'm going to talk about a really exciting change that we've brought into Simcenter STAR-CCM Plus 2402, and that's the introduction of the ability to use AMD GPUs for your CFD simulations. So specifically, we're talking about the AMD Instinct MI200 series. So that includes the MI200 GPU, the MI210, as well as the MI250. So really what we're doing is expanding the available hardware that you can leverage for GPU simulation. So, when we first introduced this 2 years ago, we started with the NVIDIA GPUs with the Volta architecture or newer, and we've continued to add more and more functionality there. So for example, like the Hopper GPUs, the H100s, as well as the Ada generation GPUs. But as I said, now we've taken it a step further again and introduced the AMD functionality. So yeah, really exciting update on that front.
Right, and anytime we port Simcenter STAR-CCM Plus on your hardware, there is always the same question. Are the two solutions exactly the same?
So yeah, we get asked about this a lot, and obviously we always try and have as close to equivalent solutions as possible between CPU and GPU, and that holds as well across, NVIDIA GPUs or AMD GPUs. From all our tests so far, we're seeing, basically really close or equivalent solutions on either hardware set, which again is a kind of key metric or a key factor of importance when you want to use these hardware types.
Excellent, right. Any new feature on the physics side? You're spoiling us with the new features every release.
Yeah, so you are correct. There's also some nice enhancements on the physics side as well. As you said, every release we try and update more and more physics models that can be run natively on the GPU. So in this release, we've introduced two really nice features that focus on conjugate heat transfer and specifically multi-timescale heat transfer. So just to kind of give a refresher, when we talk about multi-timescale heat transfer, then typically we do something like run the fluid in a steady state because the timescale is much smaller and we can reach a steady state in the order of milliseconds. And we run the solid transiently because the thermal behavior of the solid is much slower, so it can take seconds or even minutes for the temperature to kind of propagate through a solid. So in that type of scenario, then the multi-timescale modelling is a really efficient option, and it gives you really nice results. And now we can do that type of modelling all directly on the GPU. The way that we enable that is through our mapped contact interfaces. So we have the implicit and the explicit mapped contact interface, and now both of them are able to run directly on the GPU, and that kind of unlocks this multi-timescale heat transfer. So a good example of that would maybe be something like the cooling of a battery pack, where the coolant channel is running on the fluid timescale. We can run that in steady state. Then we map to the solid, which runs transiently, and that mapping is done through the explicit mapped contact interface. So yeah, we really kind of unlock a nice set of applications. The second part of this is the multi-component solid. So now the multi-component solid model is also able to be used directly on GPU. And as the name suggests, that is useful for situations where we have a complex assembly of parts with different material properties, and we want to obviously apply different solids to each component. So by having that able to run directly on the GPU, then it also kind of unlocks more complex conjugate heat transfer type simulations where we have lots of different parts with lots of different material properties. So effectively, we put those two new features together, then it really is again another quite nice step forward in terms of our ability to leverage GPUs for conjugate heat transfer type applications.
Thank you, Liam. So you're still spoiling us.
Yes.
Also this release. Quick question, all the features that you mentioned today, are they working both on NVIDIA and AMD GPU?
Yes, exactly, that's a really good question. So, no matter what type of GPU that you use, then all the physics models that we've already ported to GPU, up to and including the latest set, they can be used on any GPU type that we support. So, NVIDIA with the Volta architecture or newer, and AMD from the Instinct 200 series going forward. So all the physics that was previously available, still available on any of the supported GPU types, and you can get then all those benefits. So, faster turnaround time, increased simulation throughput, reduced energy costs, reduced capital costs. So yeah, plenty of benefit and more physics as well.
Very well. So, Liam, thank you very much for being with us today.
No problem, thank you.
Look forward to seeing you soon.
Yep, speak soon. Thanks very much.
Laura, back to you. So if I had to find a common thread on all the features we have presented so far is go faster, where go faster doesn't only refer to running faster, but it is actually go faster across all the spectrum. Think of the feature presented by Costas, the interactive classification of part surfaces in surface repair. So the feature that you are going to present now actually is still along this thread of go faster.
Yes, so this enhancement is about the segregated species that is now compatible with the coupled flow and energy solver. And this is an alternative to run the fully coupled flow, energies and species solver. So the fact that you can now run the species transport in a segregated way allows to greatly reduce the computational time.
Right, can you give an example of application and speed up?
Sure, so one example could be a rotating detonation rocket engine that you can see on the screen. It has been solved with unsteady LES, 13 species, and with complex chemistry. And for this specific application, we can see a speed up in the simulation time with a factor 10 compared to the fully coupled model.
Right, speed up 10 is absolutely impressive. We should probably remember that some applications may still benefit from running couple species, so this method is faster, may not apply to all the applications that you want to solve.
Yeah, that is correct.
Okay, so Laura, we are not moving to anyone else now, you are staying here to talk about two other new enhancements in Simcenter STAR-CCM Plus.
Yes, so in Simcenter STAR-CCM Plus 2402, we have now the Design Manager integrated into Teamcenter. Within Teamcenter, we now rely on the same mechanism already in place for heats. That means that you can start your design exploration project directly within Teamcenter and launch your simulation also within Teamcenter, or do it as before and launch your simulation project and open Design Manager directly from Simcenter STAR-CCM Plus. Working with Teamcenter allows to have all the updates from the other teams that work on the same project. The main benefit is to accelerate the time to market by leveraging the Teamcenter capabilities. That basically means that you can access the right data directly in Teamcenter. You can ensure proper traceability between the requirements and the results, and you can leverage the centralized database. The second benefit is to enhance the collaboration cross-organization. That means that you can share and manage information, push and pull data to and from Teamcenter, and submit or send back the results. You will be aware of the changes with notification. Those changes can be either geometry modification, either requirements modification, or parameter changes. So in summary, this feature greatly democratized the design exploration project as you now have an embedded study launch in your active workspace. All right, next announcements, we're gonna be looking at this application. So this is a spaceship. The spaceship is made of metal and glass, and the glass of this capsule goes through absorption and scattering from the sun radiation. And so to be able to accurately model this phenomena, we use the volumetric Photon Monte Carlo model. This is added to the existing radiation models, so the dome, the surface to surface, the surface Photon Monte Carlo, and so forth. So the Photon Monte Carlo model is the highest fidelity solution approach that we have implemented in Simcenter STAR-CCM Plus. It has the most accurate modeling of complex phenomena like absorption and scattering of the radiation source when it interacts with the participating media. In addition, compared to the dome that solves the radiation only on a fixed number of direction, the Photon Monte Carlo model solves radiation in any direction using a statistical approach.
Right, and so you spoke about accuracy clearly. Are there other benefits apart from accuracy?
Sure, the volumetric Photon Monte Carlo is compatible with volume of fluid, so VOF, like for additive manufacturing application, like directed energy deposition. The other benefit is CPU time. The volumetric Photon Monte Carlo model works in conjunction with the surface Photon Monte Carlo model. So thanks to this hybrid volume surface scheme, you can use the volumic method only in the regions where absorption accuracy is needed, while using the surface model in the other region. And so this allows to achieve a speed up of up to 37 times faster compared to a pure dome solution for an example of an optic simulation.
Okay, so thank you very much, Laura. And for the next feature, yes, as usual, wait here, but we connect to a colleague remotely. And let's see, I think he must be ready now. Yes, I can see him. Hello, Michael. How are you today?
Hey, Rodolfo. Hey, Laura. I'm doing great, thanks. And thank you for having me here.
Okay, so you are talking to us about a feature related to FSI, fluid structure interaction. I can tell you that having worked with FSI before, I saw some of the videos of applications where this feature was used, and I'm quite impressed.
In fact, we've been working on a whole set of features that enable FSI applications with a strong two-way coupling where a dense fluid interacts with a flexible structure and vice versa. This is one of the most intricate challenges in the realm of multiphysics, and convergence and stability are usually very hard to achieve in these simulations. So that is why in Simcenter STAR-CCM Plus 2402, we introduced the new dynamic FSI stabilization, which gives you very good control over the simulation with only one adjustable coefficient while being fully compatible with the solid stress load step solver. And with the backward differentiation time integration scheme now also being available for the solid stress solver, full kinematic consistency between solid and fluid is now ensured, even for setups using second order time integration. On the animation on that slide, you can see such an application where you have a thin, flexible membrane interacting with a sloshing fluid inside of a moving tank. But that's of course not the only type of application that is enabled by the new features. Would you like to see a few more? So what you see here is a column of water sitting on top of a very flexible membrane, and gravity is accelerating the water. This type of application is extremely difficult to simulate because of the large mass of water that needs to be accelerated by the thin, flexible membrane. However, our new dynamic FSI stabilization makes it work. Another super interesting application is this prosthetic heart valve, which we have also covered in one of our newest blog posts. The valve opens and closes because of the changing blood pressure acting on the leaflets. But when those leaflets start moving, they need to accelerate a large mass of blood around them. We were able to show that disregarding these strong two-way coupling effects in a simulation will lead to an over-prediction of the valve dynamics and the wrong prediction of the shape of the valve opening. So in the worst case, the valve in reality will not be able to open and close quickly enough, largely increasing the workload on the heart.
Okay, thanks a lot, really, I'm impressed. I can tell you that I was supporting a client quite involved in FSI simulations, and I'm sure that minutes after watching this video on YouTube, they will call us. I'm pretty sure about that.
I'm really excited and looking forward to seeing what kind of new applications our customers will be able to tackle with our next generation FSI modeling capabilities shown here.
Okay, thanks, Michael. It was a pleasure to have you here today.
Thanks, Rodolfo. Thanks, Laura. The pleasure is all mine. Bye-bye.
So, Laura, back to you. I forgot to ask, how many new features in this 2402 release?
Yes, I counted them and there are 116 new features.
116, wow, big number.
Yeah.
We are not talking about 116 new features here in this show. We don't want to spend all day and all night here. We are just presenting a tiny part. But if you want more information about either the features we are presenting today or all the others, please contact our support team, and my colleagues will be happy to help you.
And Rodolfo, among those 116 new features, what is your favorite?
I have a favorite, actually. I've been using Simcenter STAR-CCM Plus for about 15 years, actually before it was Simcenter STAR-CCM Plus, and I don't know how many hours I spent changing the function name and the field function name. And look at what we have in this release. So you can now synchronize the function name and the field function name automatically. So I know probably what you're thinking of, because I thought about exactly the same. Do you have to check that box anytime you create a field function? Actually, the answer is no, because you can automatically check that box in the main preferences of Simcenter STAR-CCM Plus, so that all the new field functions in all the new sim files you will create will be automatically synchronized, and you can forget forever about changing the function name and field function name. So Laura, we are now at the favorite part of the show, my favorite part. Are you ready?
Yes, I'm ready, I think.
Good, good. So ready for what? As usual, we ask Laura to take part to the challenge and show as many new features, new enhancements as she can in just under 3 minutes. Let's remember that the record to beat today is 13, still held by Liam.
Yeah.
Good. So let's get ready. Let's take our laptop and let's go.
Let's go.
Okay, so Laura, again, I'm ready with my stopwatch. 3, 2, 1, go!
All right, so I start with the same file already created, and I go to 3D CAD. Then here I hide one of the blocks, and I just want to show toggle body visibility.
Yes.
Then I go to one of the 3D CAD and I show the contacts, and now you will see that you have the gap distances directly in the contact. Then we can see that we can now change the size of the icons. So if you apply the global system, you see that the icons are now bigger.
I love these, especially because I'm not wearing my glasses today.
Then here we can see that we can now create tags directly from the 3D CAD viewer.
Yes.
Then what else? Yes, I will try to create fillets for 2 edges. So here I select my 2 edges. I create the fillet, and now you can see that if I input, here you can see that you can now visualize directly that one is okay, one is not.
Yes.
And if I change the value, now it's okay. Then I will create a design filter to show you that if you choose X-bound, you can now visualize the plane. And if you put in between, you can visualize the 2 planes, and you can move them directly. And if you search, you see directly the design filter I just created. Then I close 3D CAD.
90 seconds left, no pressure.
So I close 3D CAD, I just create my parts, I show the geometry view. And if I create now a new mesh operation to just create a bounded shape, you can see that now you have a new option, 1 bounded shape per part, and you see that now you have created 1 bounded shape for each capacitor. Then let me open the simulation guide, and to show you this feature, I will create a custom tree. So let me pull.
I think I know where you're going. 1 minute, less than 1 minute left.
So just to show you that now the link directly works well with the custom tree.
Yes.
Here I create a new continuum and I select SPH.
Obviously your baby.
Even if it's not relevant for this application. Then I go to the scene and I want to show you that now you can do an update and where it is. Yeah, you can now select MP4.
Good, export videos directly.
Yeah. Then it's your favorite feature. I create a new fill function.
Yes.
Let me rename it to energy. Exactly, and now you have this new option, and you see that the name is synchronized.
20 seconds left.
Then here I just want to show you that in the scenes you have the export viewer, and if I create new plots, you have the same names here for the plots, export to Euro file.
10 seconds left.
And if you see, now you have this new monitor to just select the objects of your new monitor, of your export viewer file. And yeah, and...
Stop!
Okay. All right.
Right, let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13.
Wow.
Wow, this is a historic moment, I would say. So now Liam is not alone on the top of the ranking, but Laura, you reached him. 13 new features. Congratulations.
It's not an easy job.
Not easy at all, really. Someone may think that product managers just work with Excel and PowerPoint, but actually they tirelessly work with Simcenter STAR-CCM Plus as well, and you see that they can really perfectly use Simcenter STAR-CCM Plus, and we're very, very proud of them. So when new features are implemented, they know exactly what they're doing.
Thank you, Rodolfo.
And right, I think we reached the end of this presentation, and I hope that you at home and in your office enjoyed as much as Laura and I did. We are very, very happy to present new features, new enhancements to you. We have, as usual, some people to thank.
Yes.
And yes, it is It is really from the deep of our heart that we do this, but we want to thank all the development team, all our amazing developers, without whom all the new features that we spoke about today wouldn't be there. All the product managers, so we had Laura here, we had others, Liam, Costas and Michael presenting remotely, and all the rest of the team who's anyway who's working very hard to contribute and implementing all these features. And I think especially we want to thank all the audience watching us from home, from your office or from your home office. And again, I hope you enjoyed. And we really look forward to seeing you again at another episode of What's New in Simcenter STAR-CCM+.